Hi everyone. In this video, we're going to be talking about Chapter 5A, which is the Fundamentals of Statistics. Um, we are going to just do an introduction to statistics in this class. There is another math class that deals strictly with this branch of math. And if you go into a bachelor's degree, then that would be something that you would have to take at another point. We're going to focus on introductory level statistics in our class. And in this section video, we're actually just going to be talking about a lot of vocabulary and background information. So having said that, let's get started. So as you know, statistics is the science of collecting, organizing, and interpreting data, but it also is another way to call the data itself. The population in a statistical study is the entire set of whatever it is you're studying. It could be people, or it could be things. And a sample is a piece of that. Usually working with an entire population is not feasible. For example, trying to figure out people's opinions from the United States, it's very difficult to get a hold of every single person in the US. So what we do is we take a sample from the population and we collect data on that, and then we make generalizations later. Sample statistics, which we just refer to as statistics, describe the sample. So sample statistics go with the sample. Population parameters describe the entire population. So these are both numbers. We call them sample statistics when it's characteristics from the sample, and we call them population parameters or just parameters when we're talking about the entire set. So here is basically how this all sets up. First, we need to figure out what is the goal of the study, and then we identify the population that goes with that. Then, from there, we select randomly from this population, and that little piece becomes our sample. We conduct our study, whatever that might look like. It could be an experiment, or it could just be an observation, it could be a survey. But then we gather the data, those become the sample statistics. From there, we infer that the data that we got applies to the entire population. That might not be true, but that is how a statistical study works. So you start with the goal, figure out the entire population, randomly select from that. That gives you your sample. You do your study. That gives you your statistics. And then you apply that to the entire population again, and those become the parameters. So here's the situation that is being done, and they want you to talk about what is the population, what is the sample, what are the sample statistics, and what would be the population parameters in this scenario. So a manufacturer of light bulbs wants to determine the average lifetime of its 75-watt light bulbs. The manufacturer randomly selects 120 75-watt light bulbs to test. The average lifetime of this group is 1,007 hours. So let's talk about the population first. The population is the entire set of everything that they're trying to study. In this case, they are trying to study their 75-watt light bulbs. So the population would be all of those 75-watt light bulbs that they manufacture. The sample is the piece that they randomly select to test on, which is the 120 that got picked to do this experiment. The sample statistics are the numbers that they gather from that sample. So from that 120 that they picked from, the average lifetime turned out to be 1,007 hours. Those are the sample statistics. From there, we would generalize and say, well, if 120 of them had an average of 1,007, then they probably all have an average of 1,007. And then we apply it to the whole group. We just put the word all in front, and that becomes the parameters. So something like that. Population is all of the light bulbs. The sample is the piece that they chose. The sample statistics is the information that they got from the sample. And the population parameters is the same information, but we apply it to all. So again, population is all, sample is a piece of it. Okay, here's another one. So consider the population of Massachusetts in 2010, which consisted of 6,547,629 persons. A study is done to measure the diastolic blood pressure of that population. A sample is obtained by randomly selecting 10,000 Massachusetts residents, taking their blood pressures, and then recording the diastolic blood pressures. The average diastolic blood pressure for the sample was 78 millimeters of hemoglobin. Okay, so let's start with what the population is. The population is the entire group of whatever it is you're interested in. So in this case, that's all of the Massachusetts residents. They gave us that amount, which we don't necessarily need in this case, but it was the 6,547,629 people who live in Massachusetts. Then the sample is the little group that they picked from to do the actual study. So the sample is the 10,000 residents that got picked. The sample statistics then is the information that they got from those people, from that group. And that information was that the average was 78 millimeters of hemoglobin. So then we would assume that if that's the average from the sample, then as long as everything was done randomly, then the entire population parameter would also be about 78. So let's review that again. Population is everyone in Massachusetts. The sample is the group that got picked. The sample statistics is the information that they got from the sample. And the population parameters is that same information and then applied to the entire group. Okay, so the next topic is going to discuss how you actually come up with the sample. You want to make sure that your sample is applicable to the entire population, because that's the whole idea of a statistical study. So you want to make sure that it is a representative sample, meaning all of the relevant characteristics of the sample are the same as what the population has, so that whatever information you get from the sample, you can then apply it to the population accurately. Otherwise, your statistical study could suffer from bias. So if your sample doesn't represent the whole population, you can't generalize it that way. Then it'll lead to bias, which means that it would favor certain results, and we don't want that in our statistical study. So some ways that we do this, one of the ways is called simple random sampling. This is usually done with computers, but the whole idea is that the sample is chosen randomly from the entire group. Every member of the population has an equal chance of being selected. Systematic sampling is when we pick every kth member, it's called. So every 10th person or every 50th person or every 100th item from a list. Convenience sampling is just what it sounds like. Usually that's sampling that's done in a way that is readily available. So if something is in close proximity, for example. And then there's stratified sampling. Stratified sampling is when the items that you're being picked from in the sample would naturally divide themselves into subgroups. You might have 2 subgroups, you might have more, but they naturally divide themselves up. For example, if you're surveying people's opinions about something going on in the US, you might choose 10,000 people randomly from all of the United States population and ask them to answer some questions, and they're going to naturally divide themselves up into certain subgroups. For example, what did the women say? What did the men say? Or what did the Republicans say? What did the Democrats say? You might see more than one subgroup also within your sample. So you are conducting a survey of students in a dormitory, and you choose your sample by knocking on the door of every 10th room. They want to know what type of sampling is being done here. Since it's every 10th room, that makes it systematic. To survey opinions on a proposed new water line, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. So in this case, since all homeowners are readily available and we're picking from that, this would become a simple random sampling because every person in the population that you're interested in, which is all homeowners, had an equal chance of being selected. 50 students are selected at random for a survey about yearbook preferences from a high school that has a freshman, sophomore, junior, and senior class. In this case, since you have subgroups, the freshmen, the sophomores, the juniors, and the seniors, this would be stratified sampling because they would naturally divide up into those characteristics. And then the last one, a city government wants to conduct a survey among the city's homeless to discover their opinions about required residence in city shelters from midnight until 6 a.m. A city commissioner obtains the sample by surveying homeless people at a nearby shelter on a Sunday night. This would be a case of convenience sampling because he is going to the nearby shelter. It's close in proximity, and he's only doing it on one day. The problem with this is this might be biased results. Since he's not asking for opinions from people, from other homeless people at other shelters on different days, he's not going out on the streets and asking people for their opinion. This might lead to bias because if they're in the shelter, chances are their feelings towards the shelter are probably more positive than the people who are not in the shelter. Maybe there's only 20 people in the shelter out of 100 people total, and the 80 other people are all someplace else because they don't want to be in the shelter. But if you only interview the people who are in the shelter, chances are they're going to say that they like the shelter and they're okay with it. Okay, so now let's determine the sampling method for these examples. An IRS auditor randomly selects for audits 30 taxpayers in each of the following status categories: single, head of household, and married filing jointly. In the case like this, you have different subgroups, so that's stratified. People Magazine chooses its 25 best dressed celebrities by looking at responses from readers who mailed in a survey printed in the magazine. This would be convenience sampling because they're just publishing something that people brought back to them. Chances are, if they're looking at who they think is best dressed by people who read this magazine, it's going to be biased towards a certain socioeconomic status group who are able to buy that type of magazine or are interested in celebrities. And then last, every 100th computer chip that is produced is given a reliability test. This would be systematic because it's every 100th chip. Okay, now let's talk about different types of statistical studies. The first one is an observational study, which means you are observing. You are not influencing or modifying anything about the study. You are just watching and you are not interfering. In an experiment, you actually set up the thing that you're trying to study and you manipulate a variable to see what the effects would be. In a case like this, you need a treatment group and you need a control group. A treatment group is the group that gets whatever it is you're studying, and the control group does not. And that way, you can see whether or not the treatment is actually working. Because if the control group has no data and the treatment group does, you can assume that the treatment is actually working. But you do need to make sure that both groups are selected randomly and have everything in common for whatever it is you're studying. A case control study is an observational study that looks like an experiment because let's say it's people, they will naturally divide themselves up into what looks like a treatment group and what looks like a control group. You don't actually put them in those groups though. You just let them put themselves in. The people who engage in the behavior would be the cases, and the people who do not are still called the controls. So the cases are like the treatment group. The controls are the participants who do not actually do whatever it is you're looking at. You would use a case control study mainly for a situation that would be unethical to set up yourself. Another reason for a control group is to remove this thing called a placebo effect. When you give the control group something, you need to give it to them to make them think that they are getting the treatment. That's the placebo. It's usually something like a water pill where it doesn't have any actual ingredients in it at all. Because the placebo effect is a psychological phenomenon where people who are given nothing actually believe that they're getting better just from the sheer fact that they thought that they were getting treatment. Blinding is another thing that needs to be done when you're talking about an experiment. Blinding is when you keep people in the dark about who's in the treatment group and who's in the control group. There's two different types. Single blind is when the participants don't know what group they're in. The experimenters are aware, but the participants don't know. Double blind is when no one knows what's going on. So the participants don't know if they're in a treatment group or not, and the experimenters also don't know. And the reason you would double blind is if you had to do follow-up questions. You don't want the experimenters to ask leading questions that might lead to a certain response. So if the experimenters don't know, they'll be less likely to ask those types of bias questions. So for each of the following questions, what type of statistical study would be most appropriate and why? So what is the average income of stockbrokers? In a case like this, there's nothing to set up here. You literally just survey them. That would be an observational study. You just ask them what they make. For the next one, does smoking cigarettes cause lung cancer? This is a case where this would be a case control study. You wouldn't want to set up an experiment and force people to smoke and see if they actually contract cancer. That would be unethical. But you're going to find people who smoke, and there's plenty of people who don't smoke. All you need to do is watch the people who decide to smoke on their own and measure the incidence of lung cancer, and then compare that to people who don't smoke and measure their incidences of lung cancer. The people who choose to smoke would be considered the cases. The ones who don't would be considered the controls. For the next one, it wants to know if lifting weights would improve runners' times in a 10-kilometer race. So there's nothing unethical about setting up an experiment for this, so that would be the best choice here. You could have one group of runners lifting weights, and then the control group would not lift weights, and then you have them run and see what the times are. Can a new herbal remedy reduce the severity of colds? This is another experiment that could be done because since it's an herbal remedy, hopefully there aren't any negative side effects to this. We're just trying to determine if it would improve a cold or not. But you would want to double blind this in this case because for the participants, you want them to think that they're getting the treatment no matter what. So you would give the treatment group the actual remedy, and you would give the control group a placebo. And that way we could then determine whether or not they think they're actually getting better. But you would also keep the experimenters in the dark because you want to make sure that in the follow-up questioning afterwards, that they don't ask leading questions for how severe the cold is, how does that person actually really feel. You don't want the experimenters to influence the responses in any way. And then, does regular exercise lower the risk of breast cancer? This would be a case control study because some people would choose to exercise and others would not. The ones who do would be the cases, the ones who don't would be the controls. But you wouldn't want to set this up as an experiment because you wouldn't want to force people not to exercise. You can't, it's unethical to tell somebody that you cannot exercise and try to take care of themselves. But you can let them choose that for themselves. Does taking a multivitamin a day reduce the incidence of strokes? This would be a single blind experiment. You only need to give the multivitamin and then give the placebo and then measure the rate. There's no need for follow-up questions afterwards, which might influence one way or the other. Does fortified brand garden fertilizer produce larger tomatoes? This is an experiment. You don't need any blinding because you're dealing with tomatoes. Blinding only is necessary when you're dealing with an experiment that involves people. You don't need to keep the tomatoes in the dark about what they're getting or not. They don't know. And there's no follow-up questions after the fact. Which of 8 airlines has the lowest percentage of delayed flights? This is just an observational study. You literally just pull the information that's going to be readily available and determine which ones have the lowest percentage. Which of the leading brands of insect repellent provides the best protection from mosquitoes? This could be an experiment. There would be nothing unethical about testing different brands of repellent to see which one works better. If there's 2 brands, for example, that we're testing, group 1 gets brand 1, group 2 gets brand 2, and then the third group is the control group, and they would get a placebo, which wouldn't have any repellent in it at all. And then you just observe and record the results to see if one brand worked better at protecting you from mosquitoes than the other. And the last topic for this section is called margin of error and confidence intervals. So this has to do with population parameters and whether or not the sample statistics would actually work here. So the plausible range of values for the population parameter is called a confidence interval. If we report on a single value, we estimate that the population parameter is this single point. You probably won't hit it exactly with the population parameter. But if you use a range of values, chances are whatever your sample statistics were, if you apply the range to the population, you'll have a better chance of actually hitting the real population parameter. The margin of error is what's used to calculate this range. So a confidence interval is calculated this way. It's from and to. So you take your sample statistic that you got from your sample and subtract the margin of error, and then you add the margin of error. And that gives you something called a confidence interval. How confident can you be that your sample statistic actually applies to your population parameter? So here's an example. An election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority, which is more than 50, to win without a runoff. The margin of error in the poll is 3 percentage points. What is the confidence interval? So how confident can she be that she's going to win? So the interval is the 52 minus 3 and the 52 plus 3. So she's got a confidence interval between 49 and 55%. Now, what does that mean for her? Since her confidence interval lies on either side of 50, which is what she needs, she can't actually determine here what's going to happen. She could lose if she gets 49%, but she could win if she gets anything past it. Um, this confidence interval is too close to tell, though. If her confidence interval was 55 to, let's say, 60, then she could be fairly confident that she would win because the confidence interval is above the 50, which she needs. If her confidence interval was, say, something like 35 to 40, she could be pretty confident that she's going to lose then because that confidence interval would lie below, completely below, the 50% that she needs. Here's another one. In a CNN poll of 500 adults nationwide, 62% of those surveyed answered yes to the question, do you favor a law to ban the sale of assault weapons and semi-automatic rifles? The margin of error was plus or minus 4.4 percentage points. What is the confidence interval? And then based on that, would you claim that the majority of Americans support this law? So let's take a look. The sample statistic was the 62%, and it was plus or minus 4.4. So we're going to subtract 4.4 and add it. And the confidence interval then is 57.6 to 66.4. This makes it possible to say that the majority of Americans do support it because both of these endpoints are above 50%. 50% is the middle, so it looks like the majority of Americans do support that. Okay, and that wraps up section 5A. Please proceed to the next video, we're going to talk about section 5C, and then you'll be able to complete the homework that goes with both of these.